Okay. So yeah, so now look what we're doing with this. If we're going to cut the corners out of this thing and then fold the flaps up. So really all this stuff is going away over here, isn't it? Right, we're just going to throw those little corner squares away. Right? Okay, so then what you're calling X is actually going to be this distance right there. Right? And what you're calling Y is going to be that distance right there. Yeah. Agree? Okay. Now, in hindsight, did we even need to really call that? Did we need to have two variables there? If the whole distance is, I mean, maybe we could have just done one, right? Can you see a way to do that? And this is sort of maybe a better way. The whole thing from there to there is 24. Okay, why don't we just establish one variable? Because the only thing you're really varying is where you make the cut, the square cuts. Agreed? I could make a tiny cut in the corner, or I could make a bigger cut out a bigger square. And so the only variable I really need here maybe is just, what if I were to call that X from there to there? All right. Then if I do that, oops, struggling here a little bit. Then what does that make the dimensions of the folded box? The bottom, 24 minus 2x. Okay, so the bottom 24 minus 2x, agreed? I got the 24 minus the 2x. And the height would be x. Okay? Now, why is that better? One variable, sure, yeah. So now, what's our volume? Okay, so I've got the width of the base squared. So I have a square base times a height, right? So 24 minus 2x quantity squared times x, right? Okay, and now do I need a secondary equation? Heck no, we got it. That's it. I'm going to call that v of x. Let's get our domain. Okay, first things first, before we can jump into the calculus, we want to get a domain here. So what's the smallest that x could be? I mean, it could, it's up to you if you want it. 0 isn't mathematically disallowed. Mathematically, it's okay, but you know, you may or may not want to use it. It's obviously not going to work, right? 0 is going to give us 0 volume, isn't it? And so whether or not you want to include that is strictly up to you. You could either make it a rounded bracket or an open bracket, doesn't matter. It's just an endpoint, right? It's not going to be the answer. What's going to be the upper endpoint? What's it going to be? What's the biggest that x could be? And it might almost be easier just to look at the picture. It'd be 12, wouldn't it? Because if I grow this corner, this corner cutout, eventually these two cutouts are going to meet each other, and there's going to be nothing left. I've cut everything away, right? And so the upper limit would be 12. And once again, do you want to have it be open or square? It doesn't. It's up to you completely. It doesn't matter. I'm going to make it just because it seems like last time you made it open. I'll include the endpoints this time, but we know that those aren't the answers. It's somewhere in between. So now what? Now we're going to shift into calculus mode, like that. And we're just going to do calculus, right? This just becomes an old style calculus problem. So we got to differentiate this guy. Yeah. So what's that look like? Well, think about it. I mean, maybe I'm jumping the gun here. How do you propose what are our options for finding the derivative here? We could expand it out, sure. And then just distribute the x. Advantages of that? No product rule or power rule or anything. It's just going to be simple derivative then. It's just going to be 3. Can you see that when I expand that whole thing out, I'm just going to get a polynomial? Then I can just differentiate term by term, and the derivative would be trivial. Disadvantage, well, I gotta do some algebra beforehand, right? Or I could just do the calculus as it stands, and things will get smaller, but in the end, I'm gonna have to do some simplification, which involves algebra. Should we take a vote? I kind of vote on that too. I think it'd be easier to expand it, but I don't think it's gonna be a big deal either way. I think you could have done this either way, and you wouldn't have been ridiculous to do it the other way either. So if we expand that out, we are going to get 576x. Is that right? You better check my math. 576. I'm going to go ahead and distribute while I'm at it too. Oh, is that right or is that wrong? I think that's right. Figure it out. So it'd be 480 plus 480 plus 96. Yeah, that's right. That's right. And then we're going to have minus 96x squared, if I'm distributing the x, remember, plus 4x cubed. Did I do that right? What did I do? Yeah, I think so. We gotta check it out. Is that making sense? Okay. Now the calculus, we put in the work, now the calculus is easy. So, what's v prime? First term? 576. Second term? 192. Third term? Okay. Good. And finding critical numbers. Is the derivative undefined anywhere? Nope, it's polynomial. So it can't be undefined anywhere. What do we have to do? Set it equal to 0 and solve? Okay, so if we do that, if we set this guy equal to 0, 12x squared, yes we can. Minus 192x plus 576 equals 0. If we're going to solve that quadratic equation, we could maybe factor it, but before we do anything, can we simplify it? Can we whittle it down?
Take 12 out.
Yeah, we can. And because this is an equation, technically we're factoring out a 12, but being as we're factoring out a constant, and it's set equal to 0, aren't we just going to divide both sides by whatever that constant is? So why not just do this? Assuming 12 goes into all those, but I'm sure it does.
Yeah.
Yeah. So then we end up with, that's going to give us what? X squared minus 18? Is that right, 18? Yeah. Oh, hold it. No. 16? 16. Whoops. It's early.
40.
Plus 48. Okay, and now we got our choices, right? We can hopefully factor it, if not, quadratic formula. What two magic numbers multiply to 48 and add to 16? Negative 16? Say it again.
Negative 12.
12 and 4. Yeah, negative 12, negative 4. Okay. And so our answers are 4 and 12. Those are our critical numbers. Now, which of those are we going to use?
4.
Yeah, we got an endpoint at 12 anyway, right? We know that one's not going to be it, but it's an endpoint. We check those anyway. And so, yeah, it's going to be the one. We're going to get one interior critical number, which is 4. What about the second derivative? Yay or nay? Yay, for sure. Yeah, it's easy, right? Easy to do. So, differentiating term by term, we get 0.
192 and 24x.
Okay, so I'm going to turn that around and make that 24x minus 192. And while we're at it, let's go ahead and just calculate the sign for our table. What is v double prime of 4, positive or negative? 4 times 24 is gonna be
Negative.
less, right? Something much less than 192, minus 192 is negative. Okay, so let's make our table. You gotta remember all those points. Was a 0 and it was negative, so that's a sad function. That's our maximum, right? Okay. Question just wants to know, well, dimensions, I guess, huh? Yeah. So if x is 4, we'll go back to our picture. We'll fill in dimensions. So if that's 4, then this must be 16, right? So then this is going to look like, this is going to be 16 by 4 would be the box that maximizes volume. Okay, make sense? Okay. How about we look at a 310 one? We haven't really talked about those very much. The economic stuff. There's not much you need to know about economics to do these. Really, the only economics equation that we really use, pretty simple one. If R equals revenue, C equals cost, and P equals profit, how are those three related? Just using your common sense.
They all involve money.
That's true. But profit equals what?
Cost.
Revenue minus cost. The amount of money coming in minus the amount of money going out equals the amount of money you get to keep. Which is profit. And that's the one you like. Okay, so what if we have you guys have a pick? Pick for one of those? 12 on the second assignment? Okay, yeah, this is a good one. Okay, and I think what I'll do, assign 14 also? Yeah. I'm gonna do 13. 13 is just like 12 and 14. So here's what they're telling us. They're telling us that cost as a function of x equals minus 40x plus 0.02 x squared. Now what's x? We're talking about economic stuff like this, business stuff. What's the independent variable? What's the purpose of business? Yeah, to sell stuff, right? So that's the number of widgets that we just sold, right? That was called widgets in econ classes. So that's cost as a function of sales. Now, what they want us to do is they want us to find the price per unit, P, that maximizes profit. So P, little p of x, is the price per unit, and they call that the demand function for some reason. I don't know why. That's called the demand function in economics. And they give that to us as 50 minus x over 100. Okay. Now we got to build profit out of this, right? So profit is revenue minus cost. When we have cost, what's revenue going to be? If little p is the price per unit, and x is the number of units, what's revenue going to be? The amount of money, revenue is the amount of money that you're bringing in from sales, right? So if my widgets cost, thank you, my widgets cost $12 a piece and I sell 1,000 of them, what's my revenue? 12,000, sure, right? So then in terms of this stuff, what's revenue? Okay, yeah, but profit's what we're gonna end up trying to come up with an equation for, right? What's revenue gonna be? If the price per item is little p, right, is this, and the number of items is x, right? Little p times x, right? Price per item times number of items, agreed? Okay, so it's just gonna be x times p of x. So if I distribute an x through that whole thing, I just get 50x minus x squared over 100. Does that make sense? See how we get that? Okay. Does it make sense, before we move on here, that when we call this the demand function, does it make sense that the price per item would be a function, when you're selling stuff, of the number of items sold? Because what happens if I raise the price a whole bunch, the number of items that I sell? Sell a lot less, right? Okay. If I lower the price, I sell a lot more, but I don't make as much per item. And so your job as the brains behind the operation, and one that knows calculus, your job is going to be to help people set the appropriate price, so you're maximizing profits. Okay, so then profit is just going to be this stuff minus that stuff, and that's not a bad function. So revenue minus cost, which would be 50x minus x squared over 100 minus all that stuff. Let's just distribute the minus sign through. Minus 4,000 plus 40x minus 0.02x squared. Make sense? Okay, I can just combine like terms and simplify that a little bit, and then I'm just on to doing the calculus. And maybe, you guys can decide if you even want to do that part. P of x would just equal, let's see, so that's going to give me, 50x plus 40x would be 90x. I've got a minus, I'm kind of mixing up these terms, not in any order, minus 4,000, and then I've got minus x squared over 100 minus 0.02x squared. What do those add up to? What is, written as a decimal, what is x squared over 100? Same as 1/100th x squared. 0.01. Good, so minus 0.01x squared minus 0.02x squared would be minus 0.03x squared. Okay? And, yeah. Okay. And what's our domain? What's the smallest number of things that we could sell? 0. Hopefully not. The biggest? As far as we know, infinity, right? Probably not going to happen, but that's, there's no upper end to this, is there? So now it's just a matter of maximizing this function on this interval. Do you even want to do that? I mean, it's up to you guys. We can take time to do it, or would you rather just, I think setting it up is probably the big thing. You've done a whole bunch of problems like that. Do you want to finish this, or should we just look at another one? Say it again. Finish it? Okay. Okay. All right. So if we differentiate then, P prime gives us what? First term? 90. Second term? 0. It's constant. Minus third one? 0.06x. Right? And so then the second derivative is what? Negative. Good. Negative 0.06. Most importantly, it's negative, right? And so we can make our little table, and it's a pretty small one. Okay, we got to find our critical number. Where is the derivative? It's nowhere undefined. Where is it going to be equal to 0? P prime equals 0 when, what?
90 equals.
Okay, good, so when these two terms are equal, 0.06x equals 90, so x must equal 90 divided by 0.06, which is 1500, okay? Second derivative is is negative, so it's a sad face, so that's our maximum, right? Got it. Okay. So then they might want to know, probably instead of how many are we going to sell, what they want to know is based on the demand function, which you guys have given them in the past. You've done a little research and done maybe a linear regression of some data, and you've told them that this is the case. The number of items that you sell depends on the price in this way, right? And so what you have control over is what's the price going to be per item. So what would we do? Well, if we know the price is, if the number of items is 1,500, P of 1,500 is, whoops, 50 minus 1,500 over 100, which is just 15, right? 50 minus 15 is 35 bucks. There's your price. Maximize profits. Okay. Questions on that? That making sense?
Can you just go back down to the table first?
Sure. Absolutely.
Okay.
Oops. Yeah.
Alright.
Okay. Did I put did you check, did I put the video up from yesterday? Can't remember. If I didn't, I'll put them both up today. Everybody see that enough? Got it? All right, it's probably not worth going down there. Let's do one more. And then tomorrow you guys can still work on this stuff. I'll make you do Wednesday night. How's that? Okay. 24. The oil well. Okay. Yeah. Okay. Well, that's a good one. Okay. I'm going to do 23. Does everybody have a book to look at? Or can they look at a book? Why don't you take a look at this one in the book real quick. 23. Minimum cost. Very similar to 24. So a power station is on one side of a river. I'll at least draw the picture up here. How about? There's our river. Here's the power station. Call that point P. The river is 1/2 of a mile wide. And the factory is 6 miles downstream on the other side. So that's a right angle, and then this distance from there to there is 6. Make sense? 1/2 mile wide river, factory 6 miles, other side 6 miles downstream. Now, what they're telling us here is that it costs $12 per foot to run power lines over land and $16 per foot to run power lines under the river. So you need to know that. Aha, you're gonna have to go some angle, aren't you? So $12 per foot on land, $16 per foot under river, okay? And we want to minimize the cost of running this line. Okay, so what do you think? In terms of a sketch, wouldn't you agree that we're gonna probably have to aim downstream a little bit? Do you think, not that, the math will tell us this, the math gods, if we ask the right questions, will tell us the answer. But do you suppose we're gonna wanna aim straight for the factory? Probably not, and the reason being that it's too expensive, right? That it costs more to run the line under the river, so we probably wanna do a combination of kind of getting downstream a little bit, but getting across the river so we can run a cheaper line on the land on the other side, right? So something like this. Okay. What's our variable going to be then? What's the thing that we can vary? Everything's constant except for we get control. Yeah, the angle. Right? We get the point that we're aiming for is what we get to choose. So then the variable should define that somehow. Now probably we're going to we probably don't want to do this in terms of an angle. We're probably going to want to do this in terms of a distance because we're trying to find distances. But why don't we call this distance maybe from right there to right there? Or we just call that x. Does that make sense? So how far downstream we're aiming our pipeline. Okay. So then if we want to come up with a cost function, I want you to think about that for a second. What's that going to look like? Cost. We'll just kind of rough this out first. Eventually, we'll get this down to a nice equation. We're going to think about this conceptually a little bit. The cost of the total pipeline can be broken into parts, right? What parts have we got? Okay, good. So we got the cost for the water part plus the cost for the land part. Now, how am I going to find cost if what I'm given is a cost per distance? Just in general, how is cost going to be related to the rate per foot, cost per foot, and the distances up here? Like, well, for example, I'm not going to say anything. You tell me. I got to somehow come up with this cost, for example, underwater. What's that going to be? And let's just say, for now, let's just say that the distance we're going to travel underwater, for now, let's just call that d sub w. Okay, we don't want any angles in there. And don't worry about any of the algebra. You know, we don't need to worry about the angle stuff. We're just going to call that d sub w for now. We might have to figure out what that is later in terms of x. But we're just going to call it, if this is the distance we're traveling through the water, how is that related to the cost of laying the pipe along that distance? Okay, it has to do with this, doesn't it? Right? So the cost under the water equals $16 per foot times the number of feet underwater, right? So times dW, right? And then the cost over the land is going to be $12 per foot times the distance along the land. So now we just got to use the geometry of the situation to come up with a formula for those two distances. And then we've got our equation, right? They got to be in terms of x. Well, the distance along the land is pretty easy. What's that going to be? 6 minus x, right? The whole distance is 6. If that's x, then we're just going to go 6 minus x along the shoreline. So the cost along the land is just 12 times 6 minus x. Pretty simple. Okay, the other one's a little more complicated, but this is a right triangle, right? So what's the distance along the water going to be then? Now, and I know that the width here, remember, that's 1/2. Okay, But 6 minus x squared, you have the right idea. 6 minus x is that part, right? So say that again, but just correct yourself there. Okay, good. So x squared plus 1/2 squared equals that hypotenuse squared, right? Which is the distance we're looking for. So then that distance must just be the square root of x squared plus 1/2 squared. Make sense? Okay, so then the cost for the water is going to be 16 times square root of x squared plus 1/4, 1/2 squared is 1/4. Make sense? Okay, and we got it then, right? Because the total cost is just the sum of those two. And so if we put those together, we've just got 16 square root x squared plus 1/4 plus 12 times the quantity 6 minus x. How many variables in that? 1. We're set, right? We got one independent variable. Now we can shift into calculus mode and just do the stuff that you've been doing for a while. So C of x, let's distribute that 12 out. So 16, so we write that as a 1/2 power. Don't have to do calculus on it. Plus 72 minus 12x. What's our domain? What's our domain from that picture? What's the smallest reasonable x? We're not going to go backwards, right? Make no sense to make the pipeline go back there. We don't want to do that. But the shortest x could be, the smallest x could be 0. Yeah. 0 would, what would that, in terms of our story, what does that mean? X equals 0 corresponds to a pipeline that we lay straight across and then, okay. So 0 is our lower limit. What's the biggest x could be? Straight to the factory, so 6. Right? Okay. And now it's just a matter of doing calculus. Let's do this. We can knock this out. If I differentiate c prime of x, what am I going to get from the first term when I differentiate? I've got this, don't forget, I've got this 1/2, right?
Yeah.
Whoops.
So it's just gonna be 16.
So 16 is the constant, that stays out front. But what's the derivative of hand to the 1/2? 1/2 hand to the negative 1/2, right? So you gotta use chain rule, right? So if I bring that 1/2 down front, what am I gonna get? 8? 8 times the quantity hand to the minus 1/2. Keep going. Okay, times the derivative of what's inside, 2x. Okay, good. Derivative of 72, 0. And then derivative of negative 12x. Okay, not so bad, right? So then we get the equation, if we do that, let's multiply the 2 out front here, so that's going to give us, what, 18 or 16x? Just put that on the bottom, because it's a negative power, over the square root of x squared plus 1/4 equals 12, if I set that all equal to 0. Right? Now how would I solve this guy? This goes back a little bit. This goes back to probably pre-calculus. How do we solve a radical equation? Okay, yeah, let's go ahead and cross multiply first. Right? And let's finish this up tomorrow and go to the lab. How about?